Hello, computer scientists, and welcome to the midterm multiple choice section. So the second time I'm recording this because the first time my microphone wasn't plugged in. Hooray. So I'm going to try and do this a little more quickly than last time because there's 20 questions and I don't want you to be sitting around for an hour. Feel free to jump around, pause it, do whatever you need to do. All right, so question 1. In the code segment below, assume that the int variable n has been properly declared and initialized. So there's some variable n that is some value. It's intended to print a value that is one more than twice the value of n. So basically 2n plus 1. Which of the following can be used to replace the missing code so it works as intended? Int result, so declare an integer result 2 times n and then add 1 to the result. That's exactly what we want to do. So 1 is valid. Int result equals n plus 1. Result equal, no. You can't add 1 first because then you would end up with 2 more than twice the value of n, right? And then int result, wait, what? Result, no, you can't declare the int result after you use it. So 3 is not going to work either. So the answer to question 1 is 1 only. So that's A. Question 2. Consider the following 2 code segments. Assume that the int variables m and n have been properly declared and initialized and are both correct. So we have positive integers m and n, not 0. Positive. For I equals 0, I is less than m times n, I plus. So that's going to happen, say m is 5, n is 6. That'll happen 30 times. Print out A. For j equals 1, j is less than, okay, so j is 1 going to less than or equal. So that'll still happen m times. So that's 5, given, let's pretend m is 5 like before. K is 1, not 0. K is less than n. So this is going to go 1 less than n, right? Because it's going to stop when it's at n. So if we start at 1 and we go less than 6, it's only going to happen 5 times. So 1 from 1 less than or equal to will happen the right number of times. But 1 less than n will happen fewer times. So if m is 5 and n is 6, the first section prints A 30 times, but it prints B only 25 times. So the answer to question 2 is going to be C. A is printed more times than B, as long as m and n are positive. Yeah, so you can just do that with a few examples and you'll see. A equals 5, B equals 8, C equals 3. Print A plus, this is basic PEMDAS, right? This is order of operations from 6th grade math. So the plus doesn't happen first, right? Multiplication and division happens first. So B divided by C, so extra trick, right? This is integer math. So B divided by C, 8 divided by 3, they're both integers, is going to be 2, right? Because 3 only goes into 8 2 times, and there's some remainder, but integer doesn't care. Integer math always results in integers. It just chops off whatever's at the end. It doesn't do rounding. So 8 divided by 3 is 2. You multiply that by 2, you get 4, and then finally you add A. So the answer here is 9. So question 3 is D. Question 4, old string A, B, C, D, E, F. New string is the old string substring 1 to 3 plus old string substring 4 and print out. Okay, so basically what we really need to do is think of this like a highway. So mile 0 is before the A, mile 1 is after the A, before the B, mile 2 between B and C, mile 3 between, so if you think of it that way, then substring from 1 to 3, from mile 1 to mile 3, right, starts between A and B and ends between 1, 2, 3, between C and D. So the first part here, substring 1, comma 3 is going to give us back BC. And then substring 4 is going to start at mile marker 4. So 0, I'm starting at mile 0, then 1 AB, 2 BC, 3 CD, 4 is between D and E. And because it doesn't have a second parameter there, it just goes to the end. So it's going to be EF. So the new string is BC plus EF. Print out the new string, you get C, BCEF. Question 5. Public class sum method. Oh God, that's a terrible name for a class. Public void 1 takes a parameter first. Public void. Oh, okay. So we're overloading this method. That's the point of this class. We're just overloading these methods. The first one takes 1 integer, the second takes 2 integers, the third takes an int and then a string. So which of the following methods can be added to the sum methods class without causing a compile time error? So what they're asking you is, how can we overload one more time without conflicting with anything that already exists? So this first example, 1 with an integer, no, we already have 1 integer value, so 1 won't work. Public void 1 with a string and then an int. Yeah, that's fine because originally we had an int and then a string. So having a string and then an int is fine. Java can tell those two things apart. The third example, public void 1, same name, int first, inside. So that's 3 ints. So that's fine too. We don't have anything with 3 ints yet. So 2 and 3 are both fine. So the answer is going to be D, 2 and 3. All right, question 6. str1 equals new string advanced placement. str2, I already know where this is going. Okay, so remember, when you're comparing objects like strings, if you use the word equals, dot equals, you're comparing the contents of the object. If you use 2 equal signs, like on the right-hand side of this first example, you're asking Java whether it is literally the same object in memory. And these two things are not. Right? You created 2 new string objects that are stored in completely different places in memory. So equals equals will return false because they are not literally the same object. Whereas the word equals, dot equals, will return true because their contents are the same. The text inside them is the same. So this first if statement will be false because of the second half there. They do not point to the same equal location in memory. So it will not print A. str1 dot equals str2. Yes, the contents are the same. And yes, str1 does not equal str2. They are not the same object. So this second one is true. So it'll print out B. And then we don't care about the rest because it's going to print out B and the rest are else if. It'll just skip those. So it's only going to print B. So the answer is B. Perfect. All right, question 7. The following method is intended to determine if the double values D1 are close enough to be considered equal. Okay, so what this is saying is computers cannot do decimals properly, right? If you have, for example, 1/3, that's 0.333333 forever. I don't know about you, but my computer does not have infinite memory. So is 0.33333 with a billion threes the same as 0.33333 with a billion threes and then a 4? Right? So it has to have some kind of tolerance. And in this case, our tolerance is 0.001. So we're trying to figure out whether these two numbers are close enough within that tolerance. So which of these can do it? Well, here's the tricky part, right? Depends on which number comes first. If the bigger number comes first, and you subtract them, you're going to get a positive number. But if the bigger number comes second, you'll get a negative number. And if you get a negative number, it will always be less than the tolerance. Right? If I subtract 1 billion from 3, it's going to be a very large negative number. So we don't want it to be within the tolerance, but it's still less than, because it's negative, it's still less than the tolerance. So we need to make sure that it doesn't matter which number comes first. And the only way to do that, or the easiest way to do that, is with an absolute value. So you can literally skip all of these, because you know, right, you would have to say something like if D1 plus D2 is less than 0 and blah, 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 and do all that. Or you can just use E, take the absolute value of D1 minus D2 and compare it to tolerance. So the answer is E. That's the only one that really works. All right. Question 8. In the code segment below, assume that the A and B have been properly declared and initialized. So C is set equal to A. D is set equal to B. Then we add 3 to C. So now C is A plus 3. We subtract 1 from D. So now D is B minus 1. We convert C into a double and store it in num. Okay, so now we have a double variable num, which is equal to A plus 3. Okay, and then we divide that by D, which was B minus 1. So which of the following best describes the behavior of the code segment? Okay, so that's A plus 3 is num divided by B minus 1. So A plus 3 divided by B, no, they didn't subtract the 1 from B, so A is not right. A plus 3 divided by B, yeah, there we go. That's the one we want. Just to double check the other ones, B minus 2, no, we're not subtracting 2. 1 minus B, nope, that's wrong. A runtime error in the last line of code because num is of type double. And D, no, it's fine to go from an int to a double, right? You're just adding more precision. Going the other way might be a problem, but no, this is fine. So the answer is B. All right, 9. Consider the following is intended to find the average of 2 positive integers. Oh, I know where this is going. All right, x and y. The sum is x plus y, so these are all integers. And then we want a double value, because like, what if you have 11 divided by 5, right? If you do that without converting it to a double, you're gonna have problems, right? It's gonna be integer math, like we talked about before. So, well, that's exactly what's happening, right? Because in the parentheses here, sum divided by 2, sum is an integer, 2 is an integer. So if you have 11 divided by 5, it'll just be 2. It won't be 2.2 or whatever, right? It'll just chop off those decimals and then convert it to a double. So, yeah, I mean, technically there's no error because it would compile and run, but it doesn't, it's intended to find the average. So the error is it doesn't actually find the average if the sum is odd. So in the cast to double is applied too late. That's true. So the average will be less than expected for even no, even values are fine. If we add, the average of 6 plus 4, we'll get 10 divided by 2 is 5. Converted to a double, that's fine. The cast to double is applied too late. That's true. So the average will be greater for even. No, that's not true. D, the expression, the cast to double is applied too late. That's true. So the average will be less than the expected result for odd value. Yes, that's true. Because it's going to chop off, right? So if, so let's say we have 6 plus 5, right? And we want to get the average of 5 and 6. That's 11 divided by 2 is going to be 5 instead of 5.5. So it's going to be too small. The average will be less, even though we then convert it to a double. So the answer is D. All right, 10. Assume the Boolean values A, B, and C have been declared and initialized. Consider the following expression. All right. Not A, not A and B. Whoa, okay. I'm going to do this on paper. All right, so if you wanted to, with this one, you could go ahead and make truth tables. You could do something, you know, like A, B, C, D, and true or false, and start with, you know, 0, 0, 0, 1, and 0, 0, 1, 0, and do all 16 options. That's going to take you a lot of time. So if you want to do that to check your answer, that's great. I'm not going to do it. I'm just going to use De Morgan's laws. So if you remember, with De Morgan's laws, you can do something like this, where if you have not X or Y, that's the same thing as not X and not Y. Those are the same things, and you can check that with the truth table if you want. But I'm going to use this to help make sense of this giant mess, right? So I'm basically going to say my X here, like this looks a lot like this top thing, right? So my X here is this whole thing right here. And my Y is this whole thing right here, right? And this not is this not. So I'm going to make this into this, because it's going to make it easier for me. So not X or Y equals not X and not Y. So not blah, 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 or blah, 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 blah. This equals not A and B, and, right, not C or not D. So hopefully that makes sense. X is this thing on the left side of the OR, Y is the thing on the right side of the OR. And I just said not X and not Y is not this thing on the left and not that thing. So now these two cancel each other out. So I'm left with A and B, and then I have this thing over here again, right? If I say not this or this, it's the same as not this and not that. So I can do my same trick I just did above here, right? With, here, let me find another color. So it's going to be and not X and not Y, where in this case my X is just C and my Y is not D. So it's going to end up being A and B and not X. Sorry, not X is not C. My mistake. And not D, right? Because I'm taking not and I'm putting not D inside that Y. So it's going to be not D, and that cancels each other out. So the whole thing here, right, at the end is just going to be A and B and not C and D. So just using De Morgan's laws, you can move things around, and that ends up being answer A. Okay, so you can see the answer is A and B and not C and D. So A is the answer. All right, halfway. Question 11. The following class, public class, sum class, has a private int num attribute. Sum class constructor takes an integer and stores it in num. Public void increment doesn't return anything. It takes a parameter more and adds that to num. Okay, so that makes sense for an increment. And then we have a getter or an accessor get num that returns what num is. Okay, so that's pretty straightforward. The following code segment appears in another class. Sum class 1 is new, so it stores 100 in the class, in num inside the class, inside the object 1. It also stores 100 in the object 2, so that's fine. So we have two similar ones, but they're not the same object. 3 equals 1. So this is the same object. So anything you do to 3 happens to 1. Anything you do to 1 happens to 3, because these are literally the same object. Now they're pointing to the same place in memory. So 1.increment here increments both 3 and 1 because they're pointing to the same spot in memory. So when I print out 1.getNum, that's going to be 300 because I had 100 and added 200 to it. 2.getNum is going to be the same as it always was, 100. And 3.getNum will also be 300 because, like I said, they're pointing to the same place in memory. So it's going to print out 300, 100, 300. So the answer is C. All right. Question 12. Consider the following code segment a random process. Okay. It's supposed to set the value of the variable event to exactly one of the values, 1, 2, or 3, depending on the probability. Okay, so it should be set to 1 if the probability is 70% or less. Event 2 should be set to 2. Sorry, event should be set to 2 if the probability is greater than 70, but no more than 80. So between 70 and 80, including 80. Okay. Value of event should be set to 3 if the probability is greater than 80. The variable random number is used to simulate that. Okay, so let me just check down here. Yeah, assume the variable random number is properly declared. So that we can assume random number works. 0 to 1, I'm assuming. Okay. So which of the following initializations for random will demonstrate the code does not work? Okay, so what doesn't work about here? Event equals 0. If random number is less than or equal to 0.7, set event to 1. That's right, because 70% or less. And then if random number is, wait a minute, this should be else if. Okay, so this is the problem, right? Because it has to be greater than 70, but no more than 80. So either you, in this if state, the second if statement here, you either have to say if random number is greater than 0.7 and random number is less than or equal to 0.8, that would work. Or you could just put it in an else if, because it would only get there if it didn't go in that first if statement. That would be a better way to do it. So what's going to happen is if any number that's less than or equal to 0.7, it's going to set it event to 1. And then it's also going to set it to 2 because it's less than or equal to 0.8. It's not going to skip over that like it would if you had else if. Okay, so which one of these is less than or equal to point? Well, A would work, right? So you can go through it if you want, but it would set event equal to 1 and then set it to 2. So, all right, 13. Consider the following code segment: J equals 1. Well, J is less than 5, so that's going to happen 4 times, right? Not 5, because we didn't start at 0. And it's going to stop at 5. So 1, 2, 3, 4, and then when it gets to 5, when it increments to 5, it'll stop. So it'll happen 4 times. K equals 1, while K is less than 5. So same thing. It's going to happen 4 times. Print out K and add 1. Oh, so it's actually going to print out 1, 2, 3, 4. And then it's going to go back, increment j. So it's going to print out 1, 2, 3, 4 4 times. Which of the following best explains the effect of changing the first line of code to j equals 0? So, well, it's just going to happen everything's going to happen one more time. Right? So this whole inner loop is going to happen now 5 times because j is going to start at 0 and then 1, 2, 3, 4 and then stop. So it'll print out, it'll just run this k loop an extra time. So k will, the k loop will print out 1, 2, 3, 4. Now it'll do that 5 times instead of 4 times. So there will be 1 more value printed. No. There'll be 4 more value. Yes, because the outer loop will iterate 1 additional time. Yeah, that's the answer. There will be 1 less. No. There'll be no change. No. So B is the answer. Okay. Question 14. Consider the following method definition. The method print all characters is intended to print out every character in string starting with a character. Okay, well, okay. Print all characters takes a string. Int x equals 0. X is less than string length. That's fine. X plus plus. System.out print from string, substring, x to x plus 1. Okay, so this will print out all the characters. I mean, you could try this, but I mean, you probably should if you don't understand, but go through and work this out. It'll print out A, B, C, D, F, G all in one line, so that seems to work properly. Which choice best describes the difference, if any, in the behavior of this statement that result from changing x is less than str length to x is less than or equal to? Okay. So what they're, so the problem here is at the end, because if you try to take a substring, right, when x is equal to the length of the string to 1 past the length of the string, it'll error out because it can't take a substring past the end of the string. So the method call will print fewer characters. No, it did it right the first time, so it's not going to print fewer characters. The method call will print more characters. It'll loop more times, but it's not going to have anywhere to go, so it's not going to print more characters. It printed all of them before. The method call, which worked correctly before, will now cause a runtime error because it attempts to access a character at index 7, yes, in a string, yes. So it's C. For this example, A, B, C, D, E, F, G in particular, it's going to go through, print all of them, and then it's going to get to the end of G and try to print from the end of G to the end of the next character, but there's no character there, so it'll have a runtime error. So yeah, you can work out the details, but basically it's C. Okay. 15. Which of the following produces the output 9, 8, 7, 6, 5, 4, 3, 2, 1? Okay. Num is 10. Well, num is greater than 0. Print out, no, it's going to print out 10 first. Can't be A. Num is 10. While num is greater than or equal to 0. Print out, no. It's going to print out 10 first again. Okay, so that's not going to happen. Num is 10. While num is greater than 1. So it's 10. Subtract 1. Print out 9. Is 9 greater than 1? Yes. So print out 9. So that's a good start. Then 8, then 7. Okay, so what's going to happen when num is 2? It's going to subtract. Going to print out 1. And it's no longer greater than 1. So it's going to start at 9, go down to 1. So that's exactly what we wanted. So I'm guessing it's C, but let's just double check. D, while num is greater than or equal to 1. No, because if it's equal to 1, it's going to print out 0, which we don't want it to do. No, and that's going the opposite. So the answer is C. Okay. two code segments where the int variable choice has been properly declared and initialized. So if choice is greater than 10, print blue. Else, if choice is less than 5, print red. Okay. Else, print yellow. So if it's less than or equal to 10 and greater than or equal to 5, it'll print out yellow. Okay. B, if choice is greater than 10, print out blue. So same thing. Choice is less than 5, print out red. Oh, there's no else if. That's the difference. Okay. Okay. Assume that both code segments show the same integer value. Which of the following best describes the conditions of the initial value that will cause the two code segments to produce different output? Okay. So if it's greater than 10, it'll print blue. Else, if it's less than 5, okay. And then B, if it's greater than 10, print blue. If it's less than 5, print red. Okay, so here's the difference. If it's in the else, the last part, right? So if it's greater than 10, print blue. So let's say 20. It's going to print blue, and it's going to skip everything else. In code segment B, right, it's going to print blue, but then it's still going to check the others because that's a completely separate if-else block. So it'll print out blue, then it'll check if it's less than 5, no, print out yellow. So basically anything greater than 10 is going to print out blue and yellow in the code segment B, but will only print out blue in code segment A. So anything greater than 10, so C. So the answer to question 16 is C. All right, 17. Consider the following methods. A is greater than 0 and B is greater than 0. Okay, so that's good to know. They're both positive integers. Method 1, the loop is 0. For int I equals 0, I is less than A over B. Oh, this is integer math again. Okay. I plus plus. Whoa, okay. I think the easiest way here is with examples. So let's say A is 10 and B is 5. So is less than 10 divided by 5 is 2. So that's going to happen 2 times. It's going to return loop count 5. What if we put in 10 and 5 for the second method 2? While I is less than A, I plus equals B. Oh. That's interesting. So it's going to add B every time. Okay. What if A and B are... What if A is smaller than B? Oh, well, let's look at the answers. I think that's going to be easier than trying to figure it out. Okay. When A and B are both even... Let's just try it, right? That's the easiest way now if we don't want to kill our brain. So let's say 2 and 2. So 2 divided 2 is 1, so this is going to happen 1 time. Turn the loop count. A and B are both 2. I is less than 2. Loop count plus plus. I plus equals B, which is also 2. So, okay, so that's going to return the same value. Fine. Both odd, 3 and 3. I'll do it 1 time. No. I think it's going to be this remainder thing here. It doesn't matter if they're even or odd. You can always come up with an example. So A, the remainder of A and B is equal to 0. So let's figure out if this one, if E which one of these returns a different value. So the remainder, so let's do 11 and 10. The remainder of A and B. So the remainder will be 1. So A divided by B will be 1 with a remainder of 1. So loop count plus plus returns 1. Yeah, it would return 2 if it had a remainder of 1. So I think the answer here is D, because the body of the for loop here is run A over B times, right? And here in B, that's only true if A divided by B has a remainder of 0. If there's a higher remainder, right, then it will do this loop one more time, because it won't jump past it, right? So the key here, so let's say it's 21 and 2, right? You can see how in the top one here, 21 divided by 2 in integer math is 10. It'll happen here 10 times, right? But down here in the second part, it'll start at 0, and as long as it's less than A, 21, so it's going to go 0, 1, 2, 3, 4, 5, 6, 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, and that's 10 times. But it will also do 20 because 20 is still less than 21. So I would do some examples here if you don't quite get it, but basically the top one is only done A divided by B times every time. The bottom one, it depends on the remainder. So the answer to question 17 is D, because when the remainder is 0, the bottom loop also does it exactly A over B times. So that was a tricky question. All right, 18. Assume object references. Which of the following describes when object? Okay, so that's when they point to the same place in memory. So D, when they refer to the same object. Okay. 19. Assume that A, B, and C are variables. Typing. A equals B, and A equals C, and B equals C, so they all equal each other. A equals B, or A equals C, or, okay. Ooh. Okay. Assume that subtraction and multiplication never overflow, so we don't have to worry about that. Which of the conditions are always true if at least 2 of A, B, and C are equal? At least 2. So one of them could be off. So A is not always true if one of them is off. B is always true if at least 2 of them are. So 2 is fine. C, if at least 2 of them are equal, one of these will be 0. So the whole thing will be, so 2 and 3 are both true. Okay. Consider the following method, which is intended to return true if at least one of the contains the substring art. Otherwise, it should return. Okay, so string all adds them all together. Return all dot index of art does not equal -1. Oh, so, I mean, basically the idea is like because it joins all 3 strings together, right, without spaces or anything in between. So if one of them ends in A and the next one starts in RT, it looks like it contains art, but it doesn't because none of them individually do. Okay, so S1, S2, S3, they're in the same order. They get joined in the same order, so that's great. It makes it easier. So if you look at A, similar, and today, so when you put them together, it'd be rat trap, similart, and art would look like it's in it. So the answer here is A. So those are the multiple choice questions. Please email me or hit me up on Discord if you have any questions. Otherwise, hope you have a great day.